afternoon everyone, welcome to the channel. In today's video I want to talk about hierarchical clustering, which is an unsupervised learning technique, and it basically separates data into groups using similarity between features. So let's see how we can do that using an example. For this example, I will use one dataset which is available in sklearn. So at first I need to import the required libraries. Okay, so these are our required libraries for this work. Now we need to load the one dataset. So datasets dot load one. Okay, now let's check the shape of our data. So there are 178 samples and 13 features. We can check the feature names using this command. So we have alcohol, magnesium, color intensity, and plenty of other things. And we also have target names. So there are 3 classes of wines. Now let's create a data frame. So here pd.data frame. Columns will be wine dot feature names. We can also add the labels. Okay, so this is what the dataset looks like. Now, so we already have shown that there are 3 classes. Let's check how many samples in each class. So you can do that like this: target names dot value counts. So class 0 has 59 samples, class 1 71, class 2 48. Okay, now let's check df.sklearn. Okay, for this feature alcohol, mean is around 13 point something. For alkalinity of air, 19 point something. This is very high. So there are some dominant features among these 13. I want to use few of them. Okay, so let's select few dominant features. Now we can call it new df. So alcohol, alkalinity of ash, magnesium, color intensity, proline. Okay, let's check our new data frame. So I've selected 5 features from 13. So from 13 we have selected 5 features, and we can also check the shape. So we can see from these values are much higher if we compare with some of the features that we didn't select. So for example, malic acid, these features have low values, ash, then total phenols. So now let's plot dendrogram. It figure fixed size 10:7. Title dendrogram. I want to mention unskilled because I haven't performed scaling yet using this standard scaler. So first I want to show a dendrogram for unscaled features. So let's give it a font size 25 and plt.ytx. I am going to increase the font size here as well. So this will be 20. Now, so the unscaled dendrogram, the linkage. Let's pass the new df and method will be port. Okay, let's see. This is the dendrogram for unscaled features. Since dendrogram is basically a tree-like structure that gives us an idea of how many clusters can exist within the dataset, and normally this is used for hierarchical clustering. So currently we can see we expect 3 clusters because of 3 classes, but with these features, unscaled features, it hasn't been able to give us that. It has given us 2 clusters. So if it was able to understand the relation a little bit better, then maybe we would have gotten 2 clusters in this on brick group, green group. And these very small numbers that we cannot understand in the x-axis, these are basically 0 to 177. So in total 178 samples, and the similarity is measured, then a tree-like structure is formed. This is dendrogram. So let's now perform some scaling since this is unscaled, and let's see if our dendrogram performs better or not. So perform pre-processing. So scalar, standard scalar, scaled, scalar dot fit transform, provide our new data frame. We can check the shape as well. Shape would be the same as this one because we are just scaling, we are not dropping anything. Okay, so now create a new data frame. So we can call it scaled data frame. So df scaled e dot data frame scaled columns will be new df dot columns. Sorry, this will be underscore. Now we can see, let's see the difference. So these are unscaled features, but after scaling they are almost quite similar to each other. So now I expect the dendrogram to find better patterns. So let's check it. So for that, def scale.shape. Okay, now let's copy this part. So here we need to use the scaled, and instead of new df it will be df scaled, and this will be scaled. So now we can see the difference. We have an extra cluster here after scaling the features. And we also, for this particular dataset, we already know that there are 3 types of points, so 3 clusters are expected. Okay, now let's perform. So this will be 7. Perform hierarchical clustering with 3 clusters. So HG n clusters will be 3. Metric will be Euclidean. Linkage word. Normally word works better when performing hierarchical clustering, but several other options are available like complete, average, single, but normally word works better. Df scaled threads hg dot labels. Okay, now need to add 2 new columns to the scaled data frame. 2 new scaled data frame. So df scaled predictions. Now check. So we have added the ground truths and predictions by hierarchical clustering. We can check the shape again, not really important, but we can check it. So after adding 2 new columns, we have now 7 columns, but features are 5. These 2 are labels. Okay. Now we can also check the uniqueness of these 2 columns, ground truths and predictions. We should get 3 in both cases. So sorry, dot ground truths unique. Sorry, forgot to mention. So we have 3 different labels in these both columns, in these 2 columns. Now, so it will be 9. Clustering comparison between ground truths and predictions. So we can use confusion matrix dot confusion matrix targets spreads. So targets are actual, spreads are predictions. Let's visualize it. Figure fixed size 74. Size C bar false. Okay. Dot first mention of y level. Ground truth sorry says 25. This is the title. Party. Bracket issue. SNS. Oh, forgot to import C1. Okay, let's import it here. Okay, So this is the confusion matrix. So this is how we can interpret it. So let's copy one line for understanding. So let's copy this line. So there are 59 class 0 types of wine. So among 59, 58 have been predicted correctly as 0, but one was incorrectly predicted as class 2 wine. Similarly, in case of class 1 type, there are 71, so 61 have been predicted correctly, 5 predicted wrongly as 0, 5 wrongly as 2, and in case of class 2, 41 have been predicted correctly, 4 predicted wrongly as 0, and 3 predicted wrongly as 1. So it's not bad. It's not necessary to actually compare with the ground truths, but since in this case we have actual levels, we can afford to do that. So one final thing, and to measure a few external validation metrics. Okay, so let's print. Let's calculate adjusted rand index. And also another one, which is Folks Mellows. Folks Mellow score. So we have to just change this. So we can see 0.72. The higher it is and close towards 1, the better. Both these validation metrics. So it's not bad. It's good. If it was bad, we would have got 0.1 to 2, something like that, or even less than that. So this is how we can perform hierarchical clustering, and in this case I showed an example using sklearn's one dataset. Okay, that's the end of this video. Thanks for watching.